In this lesson, we're looking at the autoionization of water. And to do that, you're going to want a copy of this handout. It's 3 pages long. So the autoionization of water, that's basically just when our water ionizes itself. So some water molecules will react with others to produce something called the hydronium ion, which we learned about last year, and we know is H3O plus and a hydroxide ion. So our ionization of water reaction looks like this. We have water as, or 2 water molecules as reactants, and they're in an equilibrium with a hydronium ion and a hydroxide ion. And both of these are aqueous because it's not all water that does this. So we talked about before how scientists can be pretty lazy. So instead of writing out this equation like this as a whole, they shorten it up to look like this. Water is a liquid, forms an equilibrium with a hydrogen ion and a hydroxide ion. And again, both of these are aqueous. So this H2O in equilibrium with hydrogen ion plus hydroxide ion is just the short form of the green equation. And if we just remind ourselves, take a look that, remembering that our water molecule looks something like this. And when it forms a hydronium ion, it actually bonds another hydrogen, so it looks like this. So our hydronium and our hydrogen ion is really just representing, it's telling us that we have this extra hydrogen attached to a water molecule. So in a hydronium ion, the extra hydrogen ion forms a coordinate covalent bond with the oxygen, right? So it looks like this picture here. And what we know is a coordinate covalent bond is when the oxygen just gives the both electrons to form the bond. Because this is an equilibrium, we can apply the equilibrium law for the autoionization of water. And it will look something like this. Our K is going to equal the concentration of the hydrogen ion, AQ, times the concentration of a hydroxide ion, AQ, divided by the concentration of our liquid water. What happens is we take this expression and we turn it into this. We go K times concentration of liquid water equals the concentration of our hydrogen ion times the concentration of our hydroxide ion. Looks like this. We can take this, and this K times the concentration of the liquid water equals something called KW, and that equals our hydrogen times concentration of our hydroxide. So when we do that, this KW value is actually called our ion product constant for water. So we can mathematically determine our ion product constant for water because we know that In pure water, the concentrations of the hydrogen ion and a hydroxide are equal. In fact, both of them are equal to 1.0 times 10 to the negative 7 mole per liter. So we can calculate our Kw because this Kw equals the hydrogen ion concentration times the hydroxide ion concentration. And we know they've measured because they both equal 1.0 times 10 to the negative 7 mole per liter. You can do the math and you get Kw equals 1.0 times 10 to the negative 14. And because it's a K value, we don't write units, but it's also very temperature and pressure specific. So this is at standard atomic temperature and pressure, which happens to be approximately 25 degrees Celsius. So this Kw value, the ion product constant for water, we write without units. And it is very temperature specific. So if the temperature changes, the Kw changes. So what we can do is use the equilibrium equation for water to calculate the hydrogen ion or hydroxide ion concentrations because strong acids completely ionize in water. So if we look at this example, if hydrochloric acid has a concentration of 1.0 mole per liter, the solution contains almost no hydrochloric acid molecules, but contains 1.0 mole per liter hydrogen, aqueous hydrogen, and aqueous chloride ion. So if we want to calculate the hydroxide ion concentration, and it should say in a 0.15 mole per liter solution of HCl at standard atomic temperature and pressure. To do this, we know that our hydrogen ion concentration is going to equal our hydrochloric acid concentration, which has told us that it's 0.15 mole per liter. We know that Kw is going to be the hydrogen ion times the hydroxide ion. And because it's at standard atomic temperature and pressure, we know that Kw equals 1.0 times 10 to the negative 14. So we can rearrange our formula to solve for Kw. It was actually rearranging for the hydroxide ion and looks like this. We'll finish off, or we'll continue this in part B of this video lesson.